talk is on depression detection using machine and deep learning models to assess mental health of social media users. So I myself am an author on this paper, as well as I had 3 students working with me, Sneha, Ghosh, and Diptaraj from the Department of Computer Science and Engineering from the University of Engineering and Management, Kolkata, India, and also Pramita Das from the Department of Electronics and Communications from National Institute of Technology, Durgapur, India. So globally, it is estimated that 5% of adults suffer from depression, and approximately 280 million people in the world have depression. But unfortunately, mental health resources are very scarce. And also the investment in such and also investment in treatments for depression are also not that common, especially in countries like India. And people with mental and psychosocial disabilities often face stigma and discrimination, especially in developing countries who don't see these as to be treated as something of serious concern. So this kind of motivated us to come up with something that will help these people who suffer from such stigma and discrimination, but also be able to provide treatments to them all around the world. The last 2 years, especially during the pandemic, we observed that many people who were stuck at home would use social media as a window to the outside world, because throughout quarantine, people were stuck at home and all they could do was use social media as a window to the outside world. So we kind of did this feasibility study, and when we were doing our literature review, we found out that people actually use social media as a platform to express their opinions, express their feelings. And a lot of it had to do with how people who were depressed or sad would use social media as a resource to feel good, as well as to let people know that they were going through something, but not very directly, but through some sort of posts or some sort of activity on the social media, they were able to let people know that they were going through something. And when we looked at literature review, we found out that there were a lot of work that was being done to predict depression via social media. Especially Stony Brook University had this amazing blog talking about social media posts can predict depression. Then we also had journals with papers like examining public discourse about depression on Twitter and predicting depression via social media. So this kind of motivated us to combine the 2 aspects of mental health awareness being so scarce, as well as using social media as an outlet for expressing your feelings and emotions, to bring together what we proposed in this paper, which was our proposed pipeline of coming up with something called a happiness factor that helps us to understand how each user is feeling on an online social network platform. So our idea was we would collect lists of posts of every user in the network and then build a classifier that is able to label each of the posts. So we had multiple classifiers, and I'm going to talk about that in a minute, where we would feed as input all the posts of a user, and then they would label each post as being depressed or not depressed. And once we would obtain the labels, we would use these labels to come up with a data-driven formula known as the happiness factor for each user. And once we would have this happiness factor of each user, we would pass that through something called a Mars recommendation system. So what we were thinking was not only to understand what each user or how each user is feeling in a network, but at the same time, build something like a mental health resource system that helps to understand how a user is feeling. Nowadays, when we go on social media, we look at recommendations of things that usually we search, like maybe we are looking for a product, and oftentimes the recommendations which pop up are products which are similar to the products that we were searching for. So while we were coming up with this proposed pipeline, we were thinking of how coming up with a recommendation system that suggests treatments and that suggests ways in which a user can feel better about how they are going through life, or about if they are very depressed or if they are sad, maybe looking at posts or or happy memories from before can cheer them up. So it's kind of like a recommendation system, but it's a recommendation system for improving your mental health. And I'm going to talk about each of these phases. So this paper that we worked on, we broke it down into 3 phases. The first phase was to classify each of the posts of a user into their corresponding labels of depressed and not depressed. And then the phase 2 was to use that to calculate the happiness factor of each user. And then we moved on to phase 3, where we have hypothesized how we would utilize the happiness factor of each user and make personalized recommendation based on their happiness factor. So this was our proposed pipeline. So talking about our dataset description for our phase 1. So the phase 1 was a similar task to just training a classifier using a dataset. So while we were looking up datasets, these were the 3 datasets that we found. So dataset 1 had around 2,314 depressed posts that were labeled as depressed and 8,000 posts that were labeled as not depressed. Dataset 2 had more, around 400,000 depressed posts and around 500,000 not depressed posts. And we also found out dataset 3, which had 200,000 depressed posts. Now, these 3 datasets, if you look at it, most of them were large and imbalanced. So what we did was we synthesized another dataset for training our classifier. But also, we needed the posts of each user in the network. So we tried to work with Twitter to get data, real-time data from Twitter, but it took too long to get the access and to get data. So for this paper, what we did was we generated the user post list for each user in my network. So what we did was we took a collection of posts. So we created this dataset called post dataset, which was created by combining dataset 2 and dataset 3. And so we combined 10,000 random 10,000 random posts from dataset 2 and 10,000 random posts from dataset 3. And we randomly generated the post list for each of the users. So this created the list of posts for each user that we needed for phase 1. So against each user, we had a list of posts which were a randomly generated number. So once we had that, our second task in phase 1 was to train our classifier. So for training our classifier, we came up with 2 datasets. One was dataset 1, which had 2,000 depressed and 8,000 not depressed posts. But we also synthesized a dataset called dataset T, which we used from dataset 2 and dataset 3. So we had 8,000 posts of each label. So we used supervised learning. And while we were doing research to find out, because depression detection is a very common task that is performed in the natural language process community. So we looked at all the models that were mostly used for for classifying posts as depressed. So we came up with a list of machine learning and deep learning models that can be trained to classify our posts into depressed and not depressed. So that was our phase 1. Phase 2 was to come up with something called a happiness factor. So we kept it very simple. We wanted to come up with a data-driven metric to assess the depression level of each user. So the idea is this is usually when you're using the social media as a platform or as an outlet to express your emotions. Chances are that if you are really sad, you would want to make more posts. And if you feel unwell on one day, it's that one day that you have a lot of posts. So what we wanted to come up with was this data-driven metric known as happiness factor, which is nothing but the fraction of posts labeled as depressed by our classifier divided by the total list of posts that the user makes. So the happiness factor is a data-driven aspect or a data-driven metric for each user in my network. And what we did was we divided this metric into 3 levels. So we broke them down into 3 categories. Level 1 was where you have a HF or happiness factor value of 0 to 0.4. So the indication of this metric was that 40% of the posts were classified as depressed. Similarly, we had level 2 and level 3, where 50 to 70% of the posts were classified as depressed, and level 3, where 0.81 were classified as, or 80% and more were classified as depressed. So these three levels helped us to make the recommendation system more personalized. So the idea was this: if you're at level 1, then the user is depressed, but only 40% of their posts are classified as depressed. So maybe they had maybe a bad day, or they weren't feeling well one certain day. Level 2 is where 50 to 70% of their posts were classified as depressed. This meant that they were more seriously into depression above level 1, but not as much as level 3. Level 3 was the most serious aspect, where we would have 80% of the posts of the user being classified as depressed, which is the most serious, most level of depression. So these were some of the idea that we had for personalizing the recommendation system of how we can provide mental health resources to these people based on their happiness factor. So these three levels helped us to understand how we can help the users. So we came up with this recommendation system known as the Mental Health Awareness Resource System Recommendation System, or the MARS recommendation system. So this was where we would use the happiness factor that we have calculated for each user, and based on which level they are classified as, we would suggest different things. And this is very similar to a recommendation system, which is very personalized and almost all the time dependent on what you search, and that's where the recommendation comes into play. So if they were a user at level 1, then they would be recommended motivational quotes, funny videos, meditation videos, and other motivational articles. So the way we thought this was, if I'm sad, but not very serious, but if it's not a serious depression, then sometimes looking at motivational videos and funny videos makes us happy. But as the depression progresses, or as the level in this case progresses, things become more serious. So our recommendation system also improved in the recommendation process, where if now the user was in level 2, they would get, in addition to resources from level 1, it would recommend memories and pictures of friends and family. So the level 1 recommendation would be just funny videos of like maybe videos on YouTube, or motivational quotes, or motivational articles that would pop up on the user's homepage. But if they were classified as level 2, in addition to those funny videos and articles, they would also be recommended memories and pictures with friends and family. And lastly, if they were in level 3, addition to resources from level 1 and level 2, they would also be suggested therapy and recommendations to contact friends and family, and other mental health resources where they can talk to a specialist to discuss what they are going through. So all of this comes with the fact that they are classified as a user who is going through a lot of depression. And what we wanted to do was, because of the stigma and discrimination that they face, and especially in developing countries, it's oftentimes very difficult for users to express themselves or even talk to anybody. So this way, the user gets to see all these recommendations on their own personal page. And now it's up to them whether they want to utilize those resources or not. So as an online social network provider, we would be responsible, or they would be responsible to provide these resources. But whether the user uses or not, that still remains a case of probability, because we don't know whether the user would want to use it or not. But we are providing them with resources which now they have in front of them, and they might get a thought of utilizing them, which earlier they might be scared or face because of facing stigma or discrimination. So this was kind of our idea, to combine the fact that social media uses, social media is used as a platform by users to express their opinions and feelings. And also at the same time, the technology of recommendation system helps them to come up with resources that will help the users to overcome whatever they are going through during their life. So this is what the results. So we focus mainly on phase 1 and phase 2. And the performance of different models. So we looked at all these machine learning models. So we had the multinomial naive Bayes, the support vector machine, decision trees, and k-nearest neighbors for our machine learning models. And we got a 96% for the support vector machine. But then we also looked into deep learning models like LSTM and universal sentence encoder and the sequential model. And we found out that the universal sentence encoder, which is a very rare model, which is not used much, it's a classification model, but it's not used that much for depression detection. So it's used mostly for clickbait detection and hate speech detection. So we thought, why not try to use that for depression detection? And we found out that that model actually gave us the best result, and we got a 98% accuracy. And when we use that classifier to find the happiness factor for the users in our data set, we found out the following happiness factors. So we've plotted the happiness factor versus the user ID. As you can see, there is a range of happiness factors for users. So the x-axis represents the user ID and the y-axis represents the happiness factor for each of the users. So based on this, what we did was we tried to find the number of people categorized into each level. And we saw that there were approximately around 433 members of the entire data set who were categorized as level 1, which made sense because majority of the people who post, probably most of their posts were not depressed. So around based on the total number of users, we had around 433 of them get classified as level 1. But surprisingly, level 2, we had 398 users who were categorized as level 2, which is 50 to 70% of their posts were depressed. But we also found out that 75 users out of the total were also classified into level 3. So this kind of motivated us to use this metric as a metric for identifying how the user is feeling on the social network. Sorry. So in conclusion, we came up with a new data-driven metric called the happiness factor, which was proposed to assess the levels of depression. So it was not that just the user is depressed or not. We wanted to bring the novelty of breaking it down into categories so that each of them can be treated differently based on their requirements, based on their personalized recommendation. So instead of just saying that this user has a lot of depressed posts and this user does not, we categorized it into 3 levels and using the happiness factor. We built a classifier with 98% accuracy for labeling posts as depressed. It was observed that approximately 44% of users in the network used in the experimentation were categorized into level 2, and approximately 8% were categorized into level 3. So it does turn out that there are people who belong to each of these categories, and our understanding was, yes, when we have a network of users, majority of them would be categorized into level 1, and that's what we saw with the result. We were surprised by the 44% users of the network being categorized into level 2, but which was also something that we were expecting, that it would be less than level 1, but it would still be a large number. And we were also expecting that level 3 would be much smaller, and that's exactly what we found out, where we had 8% of the users in the network being categorized into level 3. And the motivation behind this paper, or the proposed idea here, helps in identifying users on a social network who are expressing themselves through their posts, but may be hesitant to reach out for help. And this is what we were mainly targeting, because with our work here, we are able to provide resources to the person anonymously. So their homepage, their user page is going to reflect the resources and the recommendation based on their happiness factor. It's not something that they have to let everybody know. It's something that is only going to be available to them. That is what they are going to see on their homepage. It's not something that is going to be shown to the world. So at the end of the day, if they are hesitating from visiting somebody or talking to a professional or even talking to friends and family, all of these recommendations might help them to at least encourage them to some extent to reach out to people and express themselves. So that was kind of the basic idea that we had and the motivation for this paper. And also the happiness factor in the mass recommendation system allows for the online social network provider. So OSN is the online social network provider to assist the users indirectly through posts and suggestions to help them cope with their depression. And again, because this is such a sensitive topic and people face stigma and discrimination when it comes to depression, that this is just a small droplet, in the ocean of resources where we want to help these users indirectly through posts and suggestions so that we can help them cope with their depression. And this is kind of providing the resources to them, which earlier they would have to go out and look at, but now it's going to be available to them and they can decide whether they want to work with those resources or whether they want to reach out to people and so on. So this brings us to the future scope of the paper. So of course, the mass implementation, we weren't able to establish this with, we weren't able to test it for this paper. So that's in our future work where we want to get user information from a social network using an API and approach. And the second approach would be to build a dummy social network using object-oriented programming concepts to deploy the mass recommendation system. That is something that we are currently working on and we want to implement this. And another is acquiring real user data. So if you remember, I talked about the user post generation, which was synthetically created because we weren't able to get real user data, but that is something that we do have on our minds to extend the future work of this paper, where we want to use real data describing user profiles and their posts intended to be scraped and explored. So we've started working with Tweepy, which is an API that allows us to get all this information. So that is currently in progress, and we are building our data set of each user and their corresponding posts. And also improving the classifier. So with the state-of-art models like transformers, we really want to be able to bring up the level of the classifier as well. So the future step for this work would be to explore more state-of-the-art models like transformers to build a more reliable and robust depression detection classifier. So each of our phases, we want to extend it more. So phase one was where we would acquire the post of each user and we would classify them as depressed or not depressed. So here, the future scope for that is to get real user data, and we want to explore as many social network platforms as possible. So here we mostly worked on tweets and we worked on Twitter. So we really didn't explore more into Facebook or any other social media platform, which we intend to do in the future. The recommendation system, which is a major part of our work, we really want to perform more testing on that. And of course, improving the classifier, because the entire pipeline depends on what each post is classified as. And because the happiness factor solely depends on the labeled posts, the ratio of labeled posts that each user makes, that the classifier, the need of the classifier to be on point is very, very important. So that's another step that we really want to focus on. So this is the future scope, and this was all our paper was about. So I want to end this with a huge thank you to the Department of Mathematics and Computer Science at Santa Clara University, the Department of Computer Science and Engineering at University of Engineering and Management, and the Department of Electronics and Communication Engineering in NIT, or National Institute of Technology, Durgapur. And that brings me to the end of my talk. Any questions?